Welcome to this YouTube tutorial on NumPy. To use NumPy library in your Python code, you need to import it first using import statement and assign it to a short alias such as np. For example, you can use import NumPy as np to import the library and use the alias np to refer to its functions and classes. Creating NumPy array can be done in several ways. The most common method is to use the np.array function, which takes a list or a tuple of values and returns an array. For example, in a new cell in Jupyter Notebook, you can create one-dimensional array by passing a list of values like this. So that's the list of arrays, list of numbers. So just pass it in that function, np.array function. Then, and you can print it. Okay. Execute to get that is the one-dimensional array. To create a two-dimensional array, you can pass a list of lists of values like this. You can go ahead and print it this way. Print b. You execute, you get a 3 by 3, 3 rows and 3 columns. And similarly, a three-dimensional array can be created by passing a list of lists of values like this. You can add a cell and you can have that. So basically, it's like a list of 3 by 3 dimensional arrays. So it's a list of lists of lists. So you have 3 square brackets. I'm closing that. And inside the second bracket, square bracket, we have these lists, and it has 2 of them, this one and this one. Hopefully it's clear. And you can print it as follows, print C. So if I execute that, you see you have 2 3 by 3 arrays. So the first bracket represents a 3-dimensional array. If it's true, this second bracket only represents that. And this bracket here represents that 2-dimensional array. You can also create arrays of specific shapes and data types using np.zeros, np.ones, and np.empty function. For example, you can create a 3 by 3 array of zeros by typing np.zeros and pass a tuple 3 by 3, and then you can print it out by printing print d. If you execute that, you get a 3 by 3 2-dimensional array with all the values being floats, 0, and the data type is float. To create an array of ones, you can use np.ones, similar just the way we did for zeros, and just change these to ones. If you execute that, you get everything to be ones, and it's all floats. You can also specify the data type of the array, like instead of having, we can pass a data type in here. For example, you can pass a data type immediately after the tuple, you put a comma, and then you do that. So this will specify the data type, what you want to be displayed in that array. If I execute this, as you can see, everything has been converted to integers. Additionally, you can create arrays with evenly spaced values using np.arange function. For example, if you wanted a one-dimensional array containing only even numbers between 0 and 10 without including 10, then we use this function arange. The start index is 0 and the end index is 10, and you specify the size of those steps as 2. So 0 will be included, then 2 all the way to 8. 10 will not be included. So we can go ahead and print these out. If I print f, what I get is a one-dimensional array with everything being even. The NumPy library provides several other functions for creating arrays, such as array function, which can be used to convert inputs to NDA array, but it does not copy the input data if it's already an NDA array. The empty and the empty-like functions are used to create new arrays by allocating new memory, but they do not populate the arrays with any values like ones and zeros. The I and identity functions can be used to create square n by n identity matrix. You can check the dimension and shape of an NDA array by using ndim and shape attributes. For example, suppose you had a function f that is created using np.ones is a 3 by 3 matrix of the type integer. I can go ahead and print this. If I do that, it's a 3 by 3. To check the shape, all we need to do is call our NDA array f and then write the word shape. So this will just check the shape. If I execute that, I see that I get as a 3 by 3. Suppose now I wanted to get the dimension. What is the dimension of this? We use the function, the attribute ndim to get that. So we get it's 2 dimension. You can access elements of NumPy array using indexing and slicing, similar to how you would access elements in a Python list. For example, if you have a one-dimensional array, A assigned as follows. A is assigned np.array and has 5 numbers in a list. So we can go ahead and print that first. Print A. We see that it's a 5 elements in that array. You can access the first element of the array by using indexing, like you can use print A, and then inside the square bracket you specify index 0, which will get the first element. So if I execute that, I get 1. And suppose now we wanted to get a range of elements in that array, we can use slicing. And suppose that we wanted to get these 2, we can use slicing, and to get the slicing, we use and add a new line. So here we are getting from index 1 all the way to 3, but not including 3. So this will print out 2, and 3. That's one-dimensional array. Suppose now we had two-dimensional array, and the dimensional array has two rows and 3 columns. We can add a new line or a new cell. You can go ahead and print this just to see how it looks like. So that's B. You execute. Now, for you to get a specific element in a two-dimensional array, then we use column and row indexing. And to do that, we can access, for example, the first element in the first row and first column by simply using this. You specify the row and the column. So if I execute this, I get 1, which is in position 0, 0, meaning that it's row 0 and column 0. And suppose now we wanted to get a range. For example, you can use slicing to access a range of elements in a specific dimension, such as, suppose we wanted to get this. This is row 0, and then we want to get in that row 0, which is this one, we wanted to get the elements in index 1 and 2, because 3 is not included there. So this is what we use. We use 0 to represent the row and this to represent the column. So if I execute this, I get is 2, 3. So basically we've been able to get that. Additionally, you can use colon separator or operator to access all elements in a specific dimension, such as, for instance, if you wanted to get a whole column, you can use this. This one will mean that you want to get all the rows in column 0, which means it's column 0, both rows. So basically we expect to get 1 and 4. So if I execute this, I get 1, 4. That's basically how you can use slicing and indexing to select specific elements or a range of elements in a NDI array. NumPy provides a wide range of functions for performing mathematical operations on arrays. These functions include np.add, np.subtract, np.multiply, np.divide, np.exp, and np.sqrt for square root. For example, if you have two arrays A and B assigned, you have an array, a one-dimensional array A, and a one-dimensional array B, you can use np.add to add arrays element-wise, like this. So if I print this out, print C, this is what I get, 5, 7, 9. You can also have another operation which will subtract the elements of A minus the elements of B. For instance, you can have that np.subtract. You are taking elements of A minus elements of B. So if we print this out, we get -3, -3, -3. So what happened is that you took 1 minus 4, you got -3, 2 minus 5, you get -3, and 3 minus 6 is equal to that. So the operations is element-wise. You can also use np.multiply function to multiply the arrays element-wise. You can have another operation to multiply the elements. You can have np dot multiply a comma b. So what this will do, if we print this out, we get 4, 10, and 18. What this is doing is taking this element 1 multiplied by 4, you get 4, 2 multiplied by 5, you get 10, and 3 multiplied by 6, you get 18. To divide, you can make use of the division np dot divide a comma b, and if you print this out, we get the resulting division, which is basically you're taking 1 divided by 4, that's 0.25, 2 divided by 5, that's 0.4, and 3 divided by 6, that's a half, which is 0.5. Additionally, you can use np.exp function to calculate the exponential of each element in an array. Like you can have exponential of all elements in A. Maybe you can just print this out, print A, and at the same time we print G so that it's easy to show. We get the exponent of each. We can get the square root of this array called A. We can print H and execute. So, and this is what you're getting now. Remember, when you get a square root, automatically the values are floats. And that's basically it for the operations. There are many more, but these are the most common ones that you can use. Also, NumPy also provides functions for performing linear algebra operations such as matrix multiplication and determinant calculation. For example, you have A, which is a 2 by 2 array, and also you have B, which is also a 2 by 2 array. You can print these two. Print A and print B. If I execute that, I see that this is the first array A and this is the B. So you can use np dot function to perform matrix multiplication. And how to do that? We can do the dot multiplication like this. So we are creating C, which is np dot multiplication. So this is just the normal way of multiplying matrices. So we can print this out, say, and clearly this is giving you a 2 by 2 matrix, which is as a result of multiplying these two matrices. So, and how this works is that it's like you're taking 1 multiplied by 5 plus 2 multiplied by 7, and then you can take 1 multiplied by 6, that is 6, plus this multiplied by this 16. So basically it's 6 plus 16, which gives us 22, and that's how we multiply two matrices. Additionally, you can use np.linalg.det function to calculate the determinant of an array. Like we can use this to get the determinant of matrix. We have our matrix A and we want to get the determinant. And to get the determinant, this is the function that we use, linalg.det. So it's like you're calling linear algebra from the NumPy library, and we use the function det to get the determinant. So if I print this out, print D, I get -2 and a lot of zeros and 4 at the end. So that is the determinant of the matrix. Thank you for watching. See you in the next video. And please do remember to like, share, and subscribe